Unit 2 Surveying. 2.1 Definition of surveying. Surveying is the science and art of determining the relative positions of points on, above, or beneath the surface of the earth. It involves the measurement of angles and distances and the establishment of points on the earth's surface for the purpose of creating maps, defining boundaries, and supporting construction projects. Surveying is a crucial activity in various fields, including civil engineering, land development, geology, forestry, and urban planning. 2.2 Objectives of surveying. A. Mapping and cartography. To create accurate maps and charts that represent the physical features of the Earth's surface. To document the locations of natural and man-made features such as rivers, mountains, buildings, and roads. B. Land and property boundary determination. To establish and demarcate property boundaries. To resolve property disputes and legal issues related to land ownership. C. Construction and engineering. To provide precise measurements for the planning and execution of construction projects. To ensure that structures are built in accordance with design specifications and legal requirements. D. Geodetic surveys. To establish a precise and globally consistent reference system for mapping and navigation. To determine the Earth's shape, size, and gravitational field on a large scale. E. Topographic surveys. To gather data about the natural and man-made features of a specific area, including elevation, vegetation, and water bodies. To support land use planning, environmental assessment, and infrastructure development. F. Monitoring and deformation analysis. To monitor changes in the Earth's surface over time, such as subsidence, landslides, or structural deformations. To assess the stability and safety of structures and natural features. G. Hydrographic surveys. To measure and map the features of bodies of water, including lakes, rivers, and oceans. To support navigation, port development, and environmental studies related to water bodies. H. Mining and exploration. To support the exploration and extraction of natural resources such as minerals, oil, and gas. To determine the boundaries and characteristics of mining claims. I. Urban planning and development. To assist in the planning and development of urban areas, including the layout of roads, utilities, and public spaces. To analyze and manage land use to ensure sustainable development. J. Environmental monitoring. To assess and monitor changes in the environment, including deforestation, habitat changes, and urban expansion. To support environmental impact assessments and conservation efforts. Overall, the objectives of surveying are diverse and essential for various applications, providing the foundational data necessary for informed decision-making in a wide range of fields. 2.3 Horizontal and angular measurements. In surveying, horizontal and angular measurements are essential for determining the positions and orientations of points on the Earth's surface. Various instruments and techniques are used to carry out these measurements. A. Horizontal measurements. 1. Tape measure. The simplest method for measuring horizontal distances is using a tape measure. A steel or fiberglass tape is stretched between two points, and the distance is read directly from the tape. 2. EDM. Electronic distance measurement. Electronic distance measurement instruments use electromagnetic waves to measure distances. Total stations, which combine EDM with theodolites, are commonly used for both horizontal and angular measurements. 3. GPS. Global Positioning System. Global Positioning System receivers can provide accurate horizontal positions by triangulating signals from satellites. GPS is especially useful for large-scale surveys and mapping. 4. Chain surveying. In chain surveying, a chain or a tape is used to measure distances along a series of connected straight lines. It is suitable for small-scale surveys and cadastral mapping. Figure 1. Electronic distance measurement. Figure 2. GPS surveying. Figure 3. Chain surveying. Figure 4. Theodolite. B. Angular measurements. 1. Theodolite. A theodolite is a precision optical instrument used for measuring angles in both horizontal and vertical planes. It consists of a telescope mounted on a movable base with graduated circles for measuring angles. Figure 5. Total station. 2. Total station. A total station is a modern surveying instrument that integrates theodolite and EDM capabilities. It can measure both horizontal and vertical angles as well as distances electronically. 3. Transit and vernier theodolites. Transit theodolites and vernier theodolites are older but still used instruments for measuring horizontal and vertical angles. They are equipped with graduated circles and vernier scales for precise angle measurements. 4. Digital theodolite. Digital theodolites have digital displays, making angle readings more straightforward and accurate. They often include features such as automatic leveling and data storage. It seems to be like total station. 5. Auto level. Auto levels are instruments used for leveling and measuring height differences. While they are not designed for measuring angles directly, they can be used in conjunction with stadia rods for indirect angle measurements. 6. Compass. Compasses are used to measure magnetic bearings, which can then be converted into angles. However, they are less precise than theodolites and are more suitable for rough orientation. In both horizontal and angular measurements, it's crucial to consider and correct for various factors such as atmospheric conditions, instrument calibration, and systematic errors to ensure accuracy in surveying data. Modern surveying often involves the use of advanced instruments and technologies to streamline the measurement process and improve overall precision. Figure 6. Transit and vernier theodolite. Figure 7. Auto level. Figure 8. Compass. 2.4 Bearings. In surveying, a bearing is a measure of direction expressed in degrees, minutes, and seconds. It defines the direction of a line with respect to a reference direction, usually the north direction. Bearings are commonly used in land surveying and navigation to describe the orientation of lines, boundaries, and features on the Earth's surface. There are two main types of bearings: magnetic bearings and true, geodetic, bearings. A. Magnetic bearing. Magnetic bearings are measured with respect to magnetic north, which is the direction indicated by a magnetic compass. However, magnetic north is not fixed and changes over time due to variations in the Earth's magnetic field. Therefore, magnetic bearings need to be adjusted for the local magnetic declination, which is the angular difference between magnetic north and true, geodetic, north. B. True, geodetic, bearing. True bearings are measured with respect to true north, which is the geographic North Pole. True bearings are not affected by magnetic declination, making them more reliable for long-term navigation and surveying purposes. True bearings are used in geodetic surveys and are often converted from magnetic bearings by applying the appropriate declination correction. Figure 9. True and magnetic bearing. Bearings are typically expressed in the following format. A. Three-figure bearing. It represents the angle measured in degrees, clockwise from the reference direction. For example, a bearing of 0.45 degree means the direction is 45 degrees clockwise from the reference direction. B. Four-figure bearing. It includes the three-figure bearing plus the number of minutes. For example, a bearing of 0.45 degree 30 means 45 degrees and 30 minutes clockwise from the reference direction. C. Five-figure bearing. It includes the four-figure bearing plus the number of seconds. For example, a bearing of 0.45 degree 30-15 means 45 degrees, 30 minutes, and 15 seconds clockwise from the reference direction. When working with bearings, it's important to pay attention to the reference direction, north, and specify whether the bearing is magnetic or true. Surveyors use bearings to describe the direction of property lines, boundaries, and other features on survey plats and maps, providing a standardized way to communicate direction in the field of surveying and navigation. 2.5 Leveling instruments. Leveling instruments in surveying are tools used to measure the relative height differences between points on the Earth's surface. Leveling is an essential aspect of surveying, especially in construction, civil engineering, and mapping projects. The primary purpose of leveling instruments is to establish accurate and precise benchmarks and elevation data. Common leveling instruments used in surveying. 1. Dumpy level. A dumpy level is a simple optical instrument used for leveling over short distances. It consists of a telescope mounted on a tripod, with a bubble level to ensure that the instrument is horizontal. Dumpy levels are suitable for basic leveling tasks but may require frequent adjustments. Figure 10. Dumpty level. 2. Automatic, self-leveling, level. Automatic levels, also known as self-leveling levels, are instruments equipped with compensators that automatically level the instrument. They are more user-friendly than dumpy levels, as they reduce the need for constant adjustments. Automatic levels are commonly used in construction and land surveying. Figure 11. Automatic level. 3. Digital level. Digital levels are electronic instruments that provide digital readouts of height differences. They often have built-in sensors for automatic leveling and can store measurement data digitally. Digital levels are efficient for high-precision leveling work and are suitable for both horizontal and vertical measurements. Figure 12. Digital level. 4. Carpenter's level. While primarily used in construction, carpenter's levels can be employed in basic surveying tasks for short-distance leveling. They consist of a bubble level and are designed for leveling across horizontal surfaces. Figure 13. Carpenter's level. 5. Tilting level. A tilting level is a specialized instrument used for measuring the inclination of slopes or angles. It is particularly useful in engineering projects where the slope of the terrain needs to be determined. Figure 14. Tilting level. 6. Profile level. Profile levels are designed for measuring slopes and gradients. They often have a more extended telescope and are suitable for projects where a profile of the terrain or structure needs to be established. Figure 15. Profile leveling. 7. Precision, geodetic, level. Precision levels are high-precision instruments used in geodetic surveys and other applications where extremely accurate height measurements are required. They are often used in conjunction with a leveling staff and are capable of measuring height differences over long distances. 8. Invar rod, leveling staff. A leveling staff, or leveling rod, is a graduated rod that is used in conjunction with leveling instruments to measure vertical height differences. Invar rods are made of a material with minimal thermal expansion, ensuring accuracy in various temperature conditions. These leveling instruments play a crucial role in establishing accurate elevation data, determining the slope of the land, and ensuring that construction projects are built to the specified elevations. The choice of leveling instrument depends on the specific requirements of the surveying task at hand. Figure 16. Geodetic level. Figure 17. Invar leveling staff.